Hello, this is the daily video for June 28th. Today we're going to continue looking at this idea of inference and how often inference can be a difficult task. In particular, we're going to start looking at experiments today. So typically what happens in an experiment is a researcher has two things that they think may be connected in some way. And using the experiment, they would like to show if these methods are connected. So for an example, maybe an instructor is trying out a new method of teaching and they want to see if that new method of teaching is effective or not. And so in that case, they might be comparing the new method of instruction versus the student's grades or some measurement of how a student is understanding the material. So that would just be an example of something we could do. But unfortunately, if an experiment is not set up well, what can happen is sometimes this third variable can creep in, and you're going to see that today that's either called a lurking variable or a confounding variable. And what it does is it makes the two things that we're interested in learning about look like they're connected when really, in fact, they are not. And so we're going to look at two things today. We're going to look at how to prevent confounding variables in experiments. And so part of that is going to be setting up a good experiment. Now, two things that have to be in any experiment to address confounding: you have to have randomization. In the video today, we'll talk about how we do that. And you also have to have what's called a proper comparison. So anytime you read about an experiment, you always want to check that those two things were done, because if they weren't done, then there is the possibility that a confounder is present. Now, just because those two things are addressed doesn't mean there are no confounders. You can still have a confounder even if those two things are addressed. And so the notes today are going to look at that idea. We're also going to look at what is a confounder. And so let me give you a quick example of that, and you'll see this example again later on, but I think it's a really good one. So suppose that I don't know if you guys remember the commercial several years ago where there were the sharks and they were eating the Snickers bars. Well, maybe I'm a researcher and I think, I wonder if people eat more ice cream, so if they eat more Snickers ice cream bars, are they more likely to get attacked by sharks? So in this case, I would be comparing the amount of ice cream that people eat and the number of shark attacks that there are. Well, I can tell you right now for a fact that if we actually went out and we collected some data and we looked at it, as the number of ice cream sales increase, so do the number of shark attacks. And so if I only looked at that information, in other words, I didn't look up how I set up my experiment or anything, it would appear that as ice cream sales increase, this is somehow causing more people to get attacked by sharks. But hopefully, you think, that sounds kind of weird. And in fact, it should. And then this is a case where there's a confounding variable. And so the confounding variable in this case is weather. When it's really warm outside, people tend to buy more ice cream, but also when it's really warm, they tend to be out swimming more and are more susceptible to shark attacks. And so that would be an example of a confounding or a lurking variable. And like I said in the notes today in the videos, there's going to be lots more examples of those. The problem with confounding variables is they occur quite often and they can really interfere with our inference. And so that's why it's so important to learn about confounding variables, because what happens is a lot of times, I've seen this, I'll be reading the news or I'll be looking at an article and I'll see this claim that if you do this one thing, it helps a whole lot with this one, or these two things are possibly linked. And automatically, if you go and you actually read past the news article, or sometimes you just read the news article, you can automatically see that they didn't set up their experiment properly. In other words, there was no proper comparison, there was no randomization. And since those two things weren't there, there's always the possibility of a confounder. And with the possibility of a confounder, we really can't say that two things are necessarily linked. And we're going to continue with this idea for several days, but today is just to kind of introduce them and get you to start thinking towards, how to set up an experiment and what is a confounder. So as always, if you have questions, please feel free, ask on the discussion board. I'll be monitoring it, or send me an email if you need to ask me something that way.